Good morning, everyone. Today we're kicking off Chapter 3, Lesson 1, Day 1, Constant Rate of Change. Our objective is to identify proportional and non-proportional linear relationships by finding a constant rate of change. Some of these vocab words may sound a little bit new to you, but we will obviously be covering these as we get into Lesson 1. So to get things started today, let's talk about what a linear relationship actually is. A linear relationship has a straight line graph. So basically, when we graph a set of values on an XY axis, we are going to get a straight line. And that's what signifies a linear relationship. We can tell if a relationship is linear from a graph and from a table. In the table here, notice that as the number of songs increases by 2, so we're going from 0 to 2, which is a change of 2, 2 to 4, 4 to 6, and 6 to 8. And at the same time, the time in minutes is increasing by an equal amount as well. So 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1, 3 to 4 is 1. So this is going to be really important, the fact that we've got a consistent rate of change or a constant rate of change in each of these particular situations. What's important to know is the rate of change between any 2 points in a linear relationship is the same or constant. A linear relationship has a constant rate of change. So we've got a constant rate of change here of 2, constant rate of change here of 1. We can actually work that through and make it into a fraction. Say 2 over 1 is our relationship of number of songs to time in minutes, and that would equate out to 2 songs per minute. So we'll go through some more examples to help this make sense. So let's take a look at example 1 here, where we'll be analyzing a table and see if we can find that constant rate of change. The balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? If so, find the constant rate of change. If not, explain your reasoning. So the first thing that we do is we look at the change in each of these values. So we've got number of transactions on the left and the actual account balance on the right. So we look at our transactions, so we go from 3 to 6, from 6 to 9, and from 9 to 12, which is an increase of 3 in each case. And as far as our balance column, we start out at 170, then we go to 140, down to 110, and down to 80. So that is actually a change of negative 30 in each of those cases. As the number of transactions increases by 3, the balance in the account decreases by 30. So we've got a 3 to 30 relationship there that's constant in both cases. Since the rate of change is constant, this is a linear relationship. The constant rate of change is negative 30 over 3. The negative 30 comes from the reduction in the balance, and the positive 3 comes from the number of transactions. So if we broke this down, negative 30 divided by 3 would be negative 10 per transaction. This means that each transaction involved a $10 withdrawal. So let's try a couple more examples. Remember, when you're looking for linear relationships, you're really just looking for patterns and consistency in those patterns. So let's take a look at A. We're looking at cooling water, and in the time column, we've got 5-minute increments, it looks like. So we go from 5 to 10 is plus 5, 10 to 15 is plus 5, and 15 to 20 is plus 5. And then when we're looking at the temperature column, we go 95 to 90 is a reduction of 5. 90 to 86 is a reduction of 4. And 86 to 82 is a reduction of 4. So although we've got a constant rate of change in the left-hand column in time, we do not have a constant rate of change in the right. So this example is nonlinear. So let's take a look at example B. Now we're going to be looking at a graph. So we've got time in minutes on the y-axis, and number of volunteers on the x-axis. And as we're reading our graph, at the 8-minute mark, we've got 80 volunteers. As we go 8 more minutes, so that's a plus 8, we go down from 80 to 60, which is a loss of 20 volunteers. We go 8 more minutes to 24, and we go down from 60 to 40, which is a loss of 20 more volunteers. So right now, we've got a loss of 20 volunteers every 8 minutes. To break this down to a unit rate, we can take our change in y over our change in x, and we've got negative 20, which is our change in y, over 8, which is our change in x. When we divide that, we get negative 2.5 volunteers per hour. So that's our unit rate, negative 2.5 volunteers per hour. Now, if we go back to example A, let's take a look at that unit rate. We could tell by the table that we knew that we did not have a constant rate of change. For every increase of 5 minutes in time, we did not have a proportional amount of a decrease in temp. But to look at that a little bit more carefully, if we look at a change of 5 over negative 5, so from 5 to 10 and 95 down to 90, if we divide 5 by negative 5, we get negative 1. So our unit rate is negative 1. If we take 5 and put it over a change of negative 4, 5 over negative 4 equals negative 0.8. So the fact that these two values are different, our unit rates are different. We've got a unit rate of negative 1 in the first example and negative 0.8 in the second. That's what qualifies this as being a nonlinear relationship. So for today, I'd just like you to try number 1 here. Being asked to determine whether the relationship between the two quantities shown in each table or graph is linear. If so, find the constant rate of change. If not, explain your reasoning. So we're looking at the cost of electricity to run a personal computer. So we've got our time in hours going up from 5 to 8 is 3, from 8 to 12 is 4, and from 12 to 24 is 12. Now the cost goes up from 15 to 24 is 9, from 24 to 36 is 12, and from 36 to 72 is 36. So the first thing I want you to notice is 9, 12, and 36 are not consistent or even increases, but neither is 3, 4, or 12 for time. So what we have to consider is what is our x variable and what is our y. So we've got time is always the constant. So that's our x variable, and cost is y. So we look at finding linear relationships by determining the change in y over the change in x. So we can set each of these up as a fraction. So we'll take 9 over 3, divide that out, we get 3. 12 over 4, divide that out, 12 over 4, that equals 3. And 36 over 12, divide that out, we get 3 again. So it's important to note that even though these are going up in inconsistent units, time is going up in inconsistent units, so is cost. So what's really important is, first of all, we really couldn't identify a pattern. So the next step is just identify the difference between each for time and cost. And then we just work this basic fraction, change in y over change in x. 9 divided by 3 gave us 3, 12 divided by 4 gave us 3, and 36 divided by 12 gave us 3. So that would quantify this as a linear relationship.